Hey, Sonic Entropy, Blitzy here. Have you ever used Sonic G-Level and thought to yourself, wow, I can't see anything with all of this lag? I thought not, so that's why we did it for you. What you're seeing here is real-time footage of your typical Sonic Unleashed level in full, struggling to load all at once. So, how do we fix that? Stick around and find out. And while you're here, keep in mind that that's only one of the issues we're looking to avoid from the Cyclone level editor that we're building for our fan game. If you don't know who we are already, I'm Blitzy. I'm the project lead and currently only artist working alongside my wife, who has a master's degree in computer science and who I'm even lucky to be in the same room as in the first place. Today, we'll be going over all the work completed in Week 6 for Sonic Entropy, a boost-centric Sonic fan game which, to our knowledge, is the only one currently in development that doesn't rely on Unreal, Unity, or Roblox. That's right, we're building it from the ground up in our own in-house engine. And if you'd like to learn how, you might want to check out our previous devlogs to get caught up to speed. So, without further ado, let's get into the progress we've made over the course of the past week. So last week, Pagan analyzed the way Sonic Unleashed levels were constructed by examining them using Sonic G-Level, and while she gained some important insights on level design, she also discovered that some of the larger levels were almost impossible to explore because of the editor's performance issues. So this week, she decided to improve Cyclone's rendering system to avoid running into the same issues in the future when developing complex levels for our game. This is especially important for Cyclone because, unlike most level editors, Cyclone has 4 separate viewports, which means 4 times the rendering cost. In order to speed things up, Pagan implemented 3 major optimizations. The first optimization handled visibility checks. Cyclone draws everything on screen in 2 stages. The first stage draws the 2D elements such as text or selection outlines into the foreground of each viewport, and the second stage draws the 3D object meshes and grid lines into the viewport backgrounds. However, because entities can be hidden by toggling their visibility per entity type, or per entity category, Cyclone needed to run 3 checks for every entity for each viewport in both drawing stages. That is a total of 24 checks per entity. So, for the first optimization, Pagan changed the system to perform the checks only once at the start of every frame, storing a special tag alongside entities that pass the check. This not only reduces the number of times that the checks are performed down to only 3 per entity, but also reduces the number of costly memory accesses. The second optimization handled improved frustrum culling. Frustrum culling improves performance by skipping objects which aren't visible on screen. This system was already in place for drawing the 2D elements, but wasn't done for the 3D elements. Pagan modified the system such that when the culling checks are performed for the 2D elements, another per viewport tag is added to the entities, which survive the purge to signal the 3D stage if an entity should be drawn. And for Pagan's final optimization, she implemented something called instancing. Say for example, we want to draw an object on screen, we can't directly talk to the GPU to tell it what to do because DirectX doesn't allow that. So instead, we have to issue commands to the graphics driver, which then submits them to the GPU. The CPU can still run other calculations while the GPU is actually drawing the object, but first, it has to wait for the driver to verify and submit the command before it can do anything else. This means it is significantly slower to draw thousands of simple objects than it is to draw a few very complicated ones because the waiting time scales by the number of commands submitted, not by the complexity of the object. Instancing solves this problem. Rather than drawing thousands of objects individually, we can group the objects into batches and instead draw the batches. We create a chunk of memory and fill it with information like the positions and colors of each object, and when that chunk of memory is full, we issue just one command to draw everything stored in this memory chunk. Then, while the GPU is busy doing the drawing, we can prepare another chunk of memory for the next batch of objects. This is absurdly fast and boosted the frame rate from under 60 FPS to over 300 when drawing 16,000 entities. The only drawback to instancing is that all of the entities within a batch must use the same mesh, meaning we can't group together objects with different shapes. But that's not really an issue here, because an average Sonic stage is filled with objects that look identical, such as rings, springs, and dash panels, all of which massively outweigh the number of completely unique objects such as custom rails or set pieces. With these optimizations now in place, Pagan is only a few streams away from Cyclone becoming a real, usable level editor. And that's it for this week. If you enjoy these easy-to-follow devlogs, go click the little subscribe button on YouTube so you can stay up to date. And if you'd like to follow along with more in-depth information, go follow BlitzyOS on Twitch. And if you want to go above and beyond, go ahead and smash the like button. It helps us out with visibility. Thank you for watching, and we'll be back with more news next week.